Good morning, pre-calculus class of 2021 to 2022. You're very welcome to this class. I'm pretty sure that most of you know me in person, but when we have our video call, I'll be able to introduce myself to those of you that have not yet met me in person, and I'll be able to meet some of you, get to know you. So my name, as you probably already know, is William Katumba. I have the best handwriting in the school, as you can see. Yeah, so pre-calculus will have a lesson every day. It's preparing you for calculus next year, or if you don't want to go that track, you can do statistics. Just a few pointers. Every day I want you guys to do your homework in the textbook, in the PDF textbook that you downloaded, but I also want you to fill out the 2 pages in your workbook. So you will be taking pictures of the 2 things, which I've already said, but I'm making clear again because this wasn't clear last year, and I know some of you might still ask me questions about it. So you'll take pictures of your workbook, because I need to see that you filled this in, and of the homework that you did that day, and turn them all in as one single PDF file. I hope you figured out how to use the PDF scanner apps that you did. You might be wondering, why not pictures? Well, pictures are, when you take the pictures and you submit them, sometimes they're not in order. Sometimes one picture is a better quality than the other one. So I want to avoid all of that and just deal with one single PDF file. So without further ado, let's get started with functions. Unit 1. A function is simply a relation in which each possible input, you guys have done functions before. One input value leads to one output value. So you put in one thing and then you get out one thing, right? So that's a function. Every possible input value leads to exactly, and this is what's important, exactly one output value. I hope that makes sense. I hope that's clear enough. So, for example, here you have P is one input, it goes to exactly one output. Q is also one input, it goes to exactly one output. R is also one input, which also goes to exactly one output. Now you might be saying, well, this is a contradiction. It is not. Q and R are both one inputs. I mean, each one individual distinct inputs. And sometimes they can go to the same output. That's called a 2-to-1. But 2 outputs cannot go to the same input, which is what this example here shows. See, we have 2 outputs, Y and Z, both going to the same input. That is not possible for a function. It has to be either 1-to-1 or a 2-to-1. In order for you to tell if a graph represents a function, simply draw the graph of that equation or that function, and once you draw that graph, create a vertical line, right? A vertical line anywhere on the graph. If that line cuts the graph once, that function or that graph is a function. If it cuts it more than once, like in this example, you see it cuts it here and it cuts it there. If it cuts it more than once, it is not a function. This also is not a function because the line drawn on the graph cuts it more than once. If you look at these graphs, the first one will be a function because the vertical line drawn anywhere in that graph only cuts it once. Second one is also a function because it passes the vertical line test. And the third one is not a function because it does not pass the vertical line test. Because if I drew a vertical line here, oops, it's not a vertical line. If I drew a vertical line, yep, it would cut the graph at 2 points. That is not a function. Here's an example. The table displays the age of children in years and corresponding heights. Does this graph represent, or does this table represent a function? Look at the inputs and then look at the outputs. Then ask yourself, does each input, each single input, go to one distinct output? Or does each single distinct input go to one output? This is a 5, it goes to 40, okay? But this is a 5 again, and it goes to 42. So that's not possible. We have two similar inputs that go to different outputs. If this was a 40, this would be a function, but it is not a 40. We have the same input going to different outputs. That's impossible, right? So this does not represent a function. How about this one? Is GPA, grade point average, a function of percent grade? Now, every time I say a function of, then whatever is after the of is the input, right? So that's the input, and GPA is going to be the output. So let's look at this. If the input is percent grade, what you put into the function, the input is percent grade. Look at this. You have 0 to 56. That's like 55 numbers or 56 numbers. All those 56 numbers, different inputs, are going to the same output. Then you have 57 to 61, so many numbers in there, all going to the same output. 62 to 66, all going to the same output. So you can take a second here and pause the video and see whether this is a function or not. Or you can just refer back to the very first diagram that we drew over here, there, then check if it's a function or not. All right, so remember, the input is percent grade, the output is GPA. So this is a function because it's possible for so many inputs to go to the same output, right? I hope you guys got that right. What about the second part? If percent grade is the output and GPA is the input, right? Because this was the second question has been switched. GPA is now the input. Are you able to input one number and get 56 different numbers? You guys guessed it, right? No, so that's not a function. All right, function notation is, I'm sure you've seen this before in 10th grade. When we're writing functions, we write y is a function of x. And this is how it's written. Y is a function of x. Y is equal to fx. It's read as y is a function of x. X is the input value or the independent variable, the one that does not change. And y is the output value or the dependent variable. It changes based on x. Let's look at some examples. If f of x is this quadratic equation and g of x is that quadratic equation, find the following. F of 2 means that we substitute for x as 2. So this simply means that x is equal to 2 in the function of f. So in this function of f, I'm going to substitute with x as 2. So that's going to be 2 squared plus 3 times 2 minus 4. And that's going to give me, good job people, 6. Find the following. F of 2, so that's finished. What about g of 3? That means where I have x in this function, I'm going to sub for 3. I'm going to substitute 3. So 5 minus 3 times 3 squared, which is 5 minus 27, which gives you, yep, good job people. If f of x is that, gx is that, find the following. G of x is equal to negative 7. So this is simply asking us, what value of x, what is this value of x that makes the function g equal to negative 7? That's what you're trying to find. What is that value of x that makes the function g equal to negative 7? So I'm going to solve the equation. 5 minus 3x squared is equal to negative 7. Because I know that the function g of x is defined as this, and if it's equal to negative 7, I'm simply trying to find the value of x. So if I want to solve for this, the quickest way that I do this is I take the negative 3x on the other side and bring the negative 7 to this side. Some of you might start by subtracting 5 on both sides. Really here it's algebra, so whichever way that you're used to works. Some of you might say, oh, I'm going to subtract 5 this side and then I'll subtract 5 this side, so I can isolate the 3x squared equals negative 12. That also works. And at this point, I'll divide by negative 3 and divide by negative 3 and end up with x squared is equal to 4, which means that x is equal to the square root of 4, which means that x is equal to positive or negative 2. This is very easy to forget, positive or negative, plus or minus, but please don't make those mistakes. So yeah, here the value of x that makes this function equal to negative 7 is either positive 2 or negative 2. And you can test that on the side here, you can test it. Go ahead and plug in positive 2 and negative 2 into this expression. See if it gives you negative 7. Oh, I'll expect to see that in your workbook, the testing part. If f of x is that, g of x is that, find f of a. Again, f of a simply means that I am replacing x with a. That's what it simply means. So in this whole expression, where I see x, I'm going to replace with a. Finished. G of a plus h. In this whole expression, where I have x, I will replace with a plus h. 5 minus 3 into a plus h close bracket squared. So I'm going to expand that. I hope you guys remember these expansions. A plus b squared from 9th grade is a squared plus 2ab plus b squared, right? If you don't quite remember, you can go the long way and do the FOIL. A plus b, then you FOIL it out. I'm saying the word FOIL. First, outside, inside, last. So you can expand it out and see that you'll get this expansion. So when I expand this, 3 open brackets, I'll have a squared plus 2ah plus h squared. And when I bring the 3 inside the parentheses, I'll have 3a squared plus, minus 6ah minus 3h squared. So this is g of a plus h. Okay, now the big one. What do I get when I have f of a plus h minus f of a divided by h? Now this looks weird for you because it's your first day in pre-calculus and you're like, what is happening here? What's with the a and h? So it's an idea that you will study again next year in calculus, and that idea is the derivative. So what you have to do here is remember where you have a plus h, where you have x, just plug in a plus h. So I'll have f of a plus h. In place of x, I'm going to put a plus h. So I'll have a plus h squared plus 3 into a plus h minus 4. And then all of that I'm subtracting. Where I have x, I put a. A squared minus 3a, plus 3a minus 4. And then all of this is being divided by h. I'm going to expand this out. A squared plus 2ah plus h squared plus 3a plus 3h minus 4. And then I'll go to the second parenthesis. Second parenthesis is going to be minus a squared plus 3a, minus 3a plus 4. All of that is divided by h. Okay, so I hope you can see that a squared and a squared are common. I have a positive a squared and a negative a squared, so they'll cancel out. I have a negative 3a and a positive 3a, they cancel out. I have a negative 4 and a positive 4, they also cancel out. So I'm only left with 2ah plus h squared plus 3h. Everything is divided by h. I can factor out h, because if I factor out h, I'll have, inside I'll be left with 2a plus h plus 3, all divided by h. And what do you see is that h is common, so h can cancel out. So at the end of the day, I'm only left with 2a plus h plus 3. Sorry, what? Yeah, 2a plus h plus 3. Yeah. Wait, did I make a mistake here? Okay, I think I made a mistake with this h. If I find it, I'll communicate on the chat, on the comments. If I don't, then you guys will find it because I trust you that much. H squared, 2h, h squared, that is good. 3a, 3h, that's good. Minus 4. Minus a squared, minus 3a, minus 4. A squared comes out. Yeah, no, it's fine. That's it. I'm confusing my mind with derivatives, which is not something you do until 12th grade. Yeah, don't mind me. Because at this stage, the limit as h tends to 0 would be 0, so then you end up with 2a plus 3. But ignore that part. Your answer is correct. 2a plus h plus 3. Yeah, good. Okay, express the relationship 2n plus 6p equals 12 as a function. P is a function of n, if possible. So, what simply this is asking you to do is solve for p. So, are you able to solve for p in this expression? You have 2n plus 6p equals 12. If I want to solve for p, I'm going to take off 2n on both sides. Then I'll have 6p is equal to 12 minus 2n. And then if I want, I can divide by 6 both sides. Divide by 6, divide by 6. Now I'll end up with p is equal to 12 divided by 6 is 2. 2 divided by 6 is a third. 2 minus a third n. So you have p as a function of n. That means n is the input and p is the output. Right? If you want to write this as a function, you could just say f of n is equal to 2 minus 1/3 of n. And I know that someone might be lost at this stage or confused. When you divide by 6 on both sides, it's the same thing as having p is equal to 12 minus 2n over 6. I can't really factor out anything besides 2. So that'll be 6 minus n over 6. And when I reduce that, it ends up being 1/3 into 6 minus n. It is also correct if you want to leave it at this stage. Same thing as this, right? All right, in this function, what is g of 3? When the input value is 3, what is the output value? That's what it's asking you. Input value is 3, output value is 7, so that answer is 7. What input value gives you an output value of 6? That input value is 2. I hope you can see here that the input value that gives me an output of 6 is 2. What is the value of the function when the x value is 2? So I'll go to my graph and check for the x value as 2. Oops. And I'll go up to until when I meet the graph and find that y value. So when the x value is 2, the y value is positive 1. As you can see there, the y value is positive 1. What x value gives me a y value of 4? So I'll draw a line at 4. And then I'll check, because at this line I have 2 points of intersection. So all the x values that give me those 2 points of intersection are solutions to this question. I know you might be wondering, we did a vertical line test and it said if you cut the line more than once, it's not a function. But this is not a vertical line, this is a horizontal line, right? So this is still a function. We'll talk about the horizontal line test in, I think, a later lesson. So the x values here are positive or negative 2, because if I have, positive 1, positive 3 and negative 1. I have 2 x values that give me a y value of 4 on this graph. Yeah. A one-to-one function is a function in which each output corresponds to exactly one input value. We talked about that. Each output corresponds to exactly one input value. That's a one-to-one function, right? So this right here is a one-to-one function. The one to your right is a one-to-one function. This is not a one-to-one function because this output does not correspond to, this output corresponds to two inputs. So that's not a one-to-one function. The horizontal line test helps you to check whether the function is one-to-one or two-to-one. So if you look at this graph, if I draw a horizontal line, it cuts this graph more than once, right? It actually cuts it 3 times. So that means this is not a one-to-one function. This is a 3-to-1 function. It's still a function because it passes the vertical line test, right? But it doesn't pass the horizontal line test, so it's not a one-to-one function. So the horizontal line test is used to check for a one-to-one function, and the vertical line test is used to simply check for if something is a function. This is your homework. For these numbers, you can use Desmos to graph them so that you can tell whether they're functions or not. Remember, take pictures of your work and turn it in. Good luck.